Good morning, class. Today we are working on lesson 6.7 out of your GoMath textbook. So if you don't already, make sure you tore out page 339 and 341. Pause the video if you need to go and get those pages. All right. So lesson 6.7 is on relating multiplication and division. Our essential question is, how can you use multiplication to divide? Which we've been talking about this since we began our chapter 6 journey with division. And we've talked about fact families, and we've talked about how division is the opposite of multiplication, just like subtraction is the opposite of addition. Okay, so this should actually be kind of like review. So I hope you enjoyed this lesson. Let's get started. Pam went to the fair. She went on the same ride 6 times and used the same number of tickets each time. She used 18 tickets. How many tickets did she use each time she went on a ride? On the ride, okay? So what do I need to find? Well, I need to find the number of tickets Pam used each time she went on the ride. I wrote way too big. Okay. Now, circle the numbers you need to use. We've already done that. We know that she rode the ride 6 times and she used a total of 18 tickets. So one way to do this is to use a bar model. So you can use bar models to understand how multiplication and division are related. So complete the bar model to show 18 tickets divided into 6 equal groups. In the past, when we were doing multiplication, the total would be blank, and that's what we would be solving for. But because this is division, we know the total amount. So this is going to total 18 tickets. And we have to find out how many's in each group. So I have 6 equal groups, 1, 2, 3, 4, 5, 6, because she rode the ride 6 times. Okay, the way you would write this is 18 divided by 6. All right. So because I know that multiplication is the opposite of division, I'm going to read this backwards to you, and I hope you can think of the answer. What times 6 equals 18? Three. Good. Okay. So 3 times 6 equals 18. So that means each ride costs 3 tickets. If I skip counted these up, these would go to 18. So 3, 6, 9, 12, 15, 18. So 18 divided by 6 equals 3. So Pam used 3 tickets each time she went on the ride. What if the problem said Pam went on the ride 6 times and used 3 tickets each time? How many tickets did Pam use in all? That would be a multiplication sentence. Like I told you earlier, when we used the bar model for multiplication, we had the number of groups, we had the amount in each group, we were missing the total. And we know that 6 times 3 equals 18. So this brings me to your vocabulary word for the day. Inverse operations. That might sound really confusing, and you might say, I don't know what that means, but you do know what that means. Multiplication and division are opposite operations. Opposite operations. Inverse operations, same thing. Okay? Opposite operations and inverse operations mean the same thing. So multiplication and division are inverse operation. And guess what? Addition and subtraction are inverse operations. You can think about multiplication to solve a division problem. Okay, you have most of your division Let me try that again. You have most of your multiplication facts memorized at this point in our class, which is going to help you tremendously in solving your division problems. So, for example, to solve 18 divided by 6, you would think 6 times what equals 18? And since 6 times 3 equals 18, then 18 divided by 6 equals 3. This is using inverse operations. All right, flip your page over and let's talk about another way. You can use an array to see how multiplication and division are related. Show an array with 18 counters and 3 equal rows by completing the drawing. So you can see I have 1, 2, 3 equal rows, and I have 18 counters. So I'm going to put 1 in each row until I run out. So far I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So now I can see how many I was able to put in each row. 1, 2, 3, 4, 5, 6. So this array is 3 rows of 6. 3 rows of 6. And it totals 18 because that's what we started with. All right, there are 6 counters in each row, so 18 divided into 3 equal rows is 6. The inverse operation would be the backwards. 3 times 6 is 18, or 6 times 3 is 18. Either way. The same array can be used to find the total number if you know there are 3 rows with 6 counters in each row. 3 times 6 equals 18. So use the inverse operation. Use the multiplication facts that you already know, kids, to solve these problems. All right, let's keep practicing. Use the array to complete the equation. So the first thing I'm going to tell you is the same thing I told you with multiplication. Anytime you have an array, I better see it labeled. Label how many rows, label how many in each row. Always do this so you don't make a simple counting mistake. All right, so I have 2 rows of 3 counters. I have 1, 2, 3, 4, 5, 6 counters in all. The division sentence for this array is 6, the total number, divided by 2, how many rows, and how many each row? 3. So 6 divided by 2 equals 3. Same if you wrote the inverse, it would be 2 rows of 3. 2 times 3 equals 6. Okay, now we're going to write all that out, everything we just said. Step 1, label those arrays. So 1, 2, 3, boom. 1, 2, 3, 4, 5, boom. 3 rows of 5. Looky here. 3 rows of 5 equals 15. That's 15 total. 5, 10, 15. So 3 times 5 equals 15, which also means that 15 divided by 3 is 5. Okay, this is demonstrating all the steps that you should go through in your head when using inverse operations. Number 3, label that array. I've got 2 rows, 1, 2, 3, 4, 5, 6 in each row. So 2 rows of 6 equals 12, which also means that 2 times 6 equals 12, which also means that 12 divided by 2 equals 6. Okay, go ahead and do number 4 on your own, and I'm going to sit and wait. Label the array and fill in all the blanks. Go. If you need more time, go ahead and pause the video. You should have labeled that there were 3 rows. Then you could have counted that there was 1, 2, 3, 4, 5, 6, 7 in each row. 3 rows of 7 equals 21. 3 times 7 equals 21. So 21 divided by 3 equals 7. Give yourself a pat on the back if you got that one all right. All right, let's complete these equations. 5 times what equals 40? Okay, we know our 5s, but in case you've forgotten, 5, 10, 15, 20, 25, 30, 35, 40. 5 times 8 equals 40. So if 5 times 8 equals 40, the inverse operation would be 40 divided by 5 equals 8. Remember, fact families. Don't come up with some whole new number. Fact families. Number 6. Do number 6 on your own. Okay, 6 times what equals 18? Fill that blank in. You should know that from memorizing your facts. And then answer the inverse operation of 18 divided by 6. Okay, so from the facts we've learned, we know that 6 times 3 equals 18, which tells us the inverse operation of 18 divided by 6 equals 3. The fact family has 6, 3, and 18 as their members. No one else is coming along. Okay, grab page 341. Let's keep practicing. I hope you're like, man, Mrs. Rankin, this is super easy. Should be easy. This is why we did the hard work of memorizing our multiplication facts. Makes these kinds of things much easier. Number 7, label that array. Go. Okay, I've got 5 rows of 6. 5 rows of 6 equal 30. So 5 times 6 equals 30. The inverse operation, 30 divided by 5 equals 6. The family members in the fact family do not change. Okay, I want you to pause the video, do number 8, and do number 9, and then press play again when you're finished. All right, if you're back, then that means you are finished with number 8 and number 9. So let's label it 1, 2, 3, 4. 1, 2, 3, 4, 5. 4 rows of 5 equal 20. 4 times 5 equals 20. The inverse operation of 20 divided by 4 equals 5. Number 9, label it 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 4 rows of 7 equals 28. 4 times 7 equals 28. And the inverse operation of 28 divided by 4 equals 7. Okay. Complete the equation. Okay, so here we just have 2 equations, and they are inverse operations. Here we go. 7 times what equals 21? You should all be hollering out a number right now. 3, good. We know that 7 times 3 equals 21. So the inverse operation of 21 divided by 7 will equal 3. 8 times what equals 16? 2, good. So if 8 times 2 equals 16, then the inverse operation of 16 divided by 8 is 2. Okay. All right, let's do some of these algebra problems. Remember, when we're working with equations, whatever's on each side should equal the same amount in order for the equation to be true. So you want to solve each side. You don't want to look at it and guess. So 3 times 3 equals 9, right? So 27 divided by what is going to equal 9? Okay, it needs to equal 9. 27 divided by 3 equals 9. Both sides should equal the same amount. 3 times 3 equals 9. 27 divided by 3 equals 9. That makes this equation true. Look at number 13. 16 divided by 2. Well, I know what times 2 equals 16? 8. So 16 divided by 2 is 8. So I need to know blank times 2 will equal 8. What times 2 is going to equal 8? 4. So if you put an 8 here, that's not true because it's not 16 equals blank times 2. Whatever this side equals, which is 8, is what this side should equal. 4 times 2 is 8. So now they are equivalent. The equation is true. Look at number 14. This side is solved already for you. So 9 equals blank divided by 4. Oh boy. So we need to find the big number. So what divided by 4 is going to equal 9? Well, if you do the inverse operation, okay, let me rewrite this so it looks clear to you. So this is blank divided by 4 equals 9. Okay, and if you did the inverse operation, you went backwards, it would be 9 times 4 equals what? Well, 9 times 4 equals 36. So that means that 36 divided by 4 equals 9. Okay. Let's do some word problems. Remember, circle, box, and underline with me. Here we go. Justin and Ivan went to the fair when all rides were $2 each. Each is a clue word for either multiplication or division. They each went on the same, another clue word, number of rides. Each boy, so many eaches, spent $10. How many rides did each boy go on? Okay, so the total amount of money that each of them spent was $10, right? Okay. And we don't know how many rides that they rode, right? But each ride costs $2. So $10 divided by $2, okay, would equal how many rides? What's 10 divided by 2? Well, what times 2 equals 10? 5. So that means that each boy went on 5 rides. How many rides? There's your label. Another way that you could write this is you could have said they spent $10 on blank number of rides, and each ride was $2 each. Same difference here, you would have gotten 5. So either way, doesn't matter which order you put it in. Now I'm going to circle my answer because I'm a good mathematician. I want to make sure my answer is clearly found. Rashawn has 18 crackers. He shares the crackers equally, there's a clue word, with his brother. Then Rashawn eats 3 crackers. How many crackers does Rashawn have left? So the first thing I have to do is figure out how many crackers did he have before he started eating them. So he had 18 crackers to begin with, right? If he shares the crackers equally with his brother, then how many equal piles will they go in? There should be 1 pile for Rashawn, 1 pile for his brother, so that's 2 piles. So 18 divided by 2, well, what times 2 equals 18? 9. So each of them got 9 crackers. Am I done? I am not, because it says how many crackers does Rashawn have left? When it wants to know how many somebody has left, that's a subtraction clue word. So now Rashawn has 9 crackers, right? But he eats 3 of them. So what's 9 minus 3? If you eat them, they go away. You got to take them away. Subtraction. 6. So that means that Rashawn has 6 crackers left. Find your label in your question. How many crackers? And then I'm going to circle my answer to make sure that it's clear. Okay, let's try another one. Paul is in charge of the egg toss at the World Egg Day Fair. I did not know that was a thing, guys. There are 48 people participating in teams of 8 people. Each team needs 1 egg. Paul is buying eggs in cartons and that each have 6 eggs. How many cartons does Paul need? Oh boy, guys. Okay. It's a lot of questions, right? A lot of parts, I should say. There's a lot of parts to this. Okay. There's 48 people participating in teams of 8. Okay. Each team has 8 people. All right. But it doesn't matter how many people are on each team because each person doesn't get an egg. Each team needs 1 egg. So let's figure out how many teams that we have. Okay, so let's back up. We have 48 people, and we're going to put them into groups of 8 or teams of 8. Let's see how many teams it makes. So that means 48 divided into teams of 8. Well, what times 8 equals 48? What times 8 equals 48? You should know this fact. 6. Good. Okay. So that means we have 6 teams, right? But we're not finished. Each team needs 1 egg. Okay. So how many eggs does Paul need? Well, 6 teams. Each team needs 1 egg. That totals 6 eggs. But we're still not done. The question is, how many cartons does Paul need? Well, Paul is buying eggs in cartons that each have 6 eggs. So if the cartons have 6 eggs and he needs 6 eggs, then how many cartons does he need? 1 carton. This seems like a very confusing, very long problem, but you have to break it down and do one part at a time. First part, let's take our total number and figure out how many teams we can make. Okay, boom, that's done. Now, each team needs 1 egg, so number of teams times 1 is how many eggs that they need. Okay, then look at how many eggs are in each carton. 6. Well, that's how many eggs he needs, so he only needs 1 carton. Do not get scared or nervous when you see these really big word problems. Because if you look at it, none of these problems are super difficult. You can do them. Just worry about settling one part of the problem at a time. All right, head on over to Think Central to do your assignment and have some fun.